In this problem, we're going to build a procedure that sees into the mind of a finite state machine. Given a definition for a non-deterministic finite state machine, we're going to use our crystal ball of Python code to read into the mind of the finite state machine and output any string, if there exists one, that is accepted by that finite state machine. This sounds like some pretty powerful stuff, but believe it or not, you have all the tools to do this. So here I have an outline for a finite state machine, and I didn't bother to label any of the edges. And let's just add a few more for fun. The strategy we're going to use is starting from the starting state. We're going to follow every edge, and as long as we don't visit a node that we've already visited, we're going to continue along until we reach an accepting state. We're then going to go back, building up a string that goes the other way. So the last character is going to be this edge, the second to last is going to be this one, and the third to last will be this one. Yeah, there are strings that would match if we went here and then kind of looped at the 3 for a while, but the question only asks us to give 1, and this is the best way to do it. We do have to take into account the issue of kind of an infinite loop. How do we know that we're never going to finish, never going to reach the accepting state? And I hinted at that earlier. We're just going to avoid revisiting the same node over and over again, because all we care about is making forward progress. In this one, I could follow the 1 over and over again, just looping around forever, but I'll never reach the accepting state 2. So what I'm going to say is if I follow the edge back to the 1, I haven't made any progress. So I want to stop following edges from the 1 along that path. If there so existed a second edge that led from the 1 to the 2, I would take that immediately and go right to the 2. So I can ignore the looping forever. So hopefully you're still with me. And now I'm going to walk you through, believe it or not, the recursive solution to this problem. So here I have the declaration for my procedure. The inputs are the current state, the representation of our machine, the accepting states, and the states that we've visited so far. And as a reminder, what we're going to return is none if we reach a failure point. Otherwise, we're going to start returning the edge that led us to this state, or more precisely, the next state, and build up the string as we go backwards from the accepting state. Okay. Let's go right to the base case. If we've already visited this node, we're not making forward progress, and this isn't going to lead us to the accepting state, so we're going to return none. If we're currently in an accepting state, then we're going to return the empty string. We don't need to operate on any more edges to reach the accepting state. Here, I'm adding the current state to what's going to be the new list of visited states. And here, I'm looking up all the outgoing edges from the current state. And for each outgoing edge we find, we're going to recurse with the new state in the new list of visited states. Is following that path eventually leads us back to something we've already visited, or if there are no outgoing edges, basically if we failed, then foo will be none. If it's not none, that means we found something. We found an accepting state, so we're going to start returning our string. And so the string I'm going to return is the character that I followed to the new state, plus the string that was returned by a recursive call. This string represents all the characters that took to get from new state to the accepting state. This could be an empty string. It could be 100 different characters. It doesn't really matter. And in case there are no outgoing edges, as I mentioned before, we're going to return none as well. That's it. 13 lines of code to read the mind of a finite state machine.